Hello my dear champions, welcome back to our channel Diksha Karnataka. Today I am here to deliver the last session in your Masterstroke concept lectures, yes, for the PU2 syllabus. Do not forget, we're going to bring out the question sessions that we're doing live once your boards are over, and of course we will bring out your PU1 syllabus also once your lives are over. But today I'm here to deliver the last class in the PU2 syllabus for the chapter, for the concept, for the theory lecture of Masterstroke in mathematics. Okay, so the lecture will be on what? You can see that very clearly on the screen is probability and linear programming. Two simple chapters, not many concepts are there, straightforward questions. Whether you talk about probabilities, you have independent events, conditional probabilities and Bayes theorem. That's all we can expect the questions on. Whether it is KCET, PU2, both will have a similar pattern. Even in linear programming, we'll have a graphical approach question. In CET, the question, they given the graph, they can ask you the constraints, they can ask you the objective functions, maximum, minimum value, is optimized value. But yeah, the approach remains same in both the chapters for whether KCET or PU2. Let's look at we'll look at the questions later. Right now I have brought some questions today as well, but we'll look at theory part first. Okay, and before I begin the class, I have to ask all of you to start joining our classes by simply subscribing to our channel. It's completely for free, it's not of any charge. Simply subscribe our channel and be a part of all the sessions that is coming for your benefit, whether it is boards, whether it is KCET. It will certainly helping you in your preparation. Okay, so I'm gonna start on that note with a surprise, with a gift to all of you who have already availed. Good, means already have taken this benefit from us for free. Good for you. If you have not yet, do just only one thing. You are all getting an access to free KCET mock test. Okay, you heard it right, and these are not the ABHYAS free ones. Okay, this is a separate KCET mock test that we are giving for free. Okay, one for physics, one for chemistry, one for biology, and of course for maths as well. Check here, I have taken a sample of one of the lectures integrals. If you go and check in the video's description, you're gonna find here free KCET PCMB mock test PDF. Click on the link, fill your details and get the access to PDFs right away. Okay, so do that right now and take few tests today itself if you can. At least for maths you can do that. Okay, so this is clear, sir. Your gift is ready, your surprise is ready, you got the PDFs. Once that is done, let's get back to our chapter. Yeah, so I'll keep the things to the point. We don't have much time to go and talk about many things. We'll be on the point from where the question comes. And one such topic from this chapter, probability, is conditional probability. Make sense? Yes. Actually, if you know this particular concept well, even the Bayes theorem questions can be solved using just this and the total probability. That's all. What is total probability? We'll talk about that later. But today, right now in this session, first let's talk about conditional probability. The word conditional has everything that to do with in this particular concept. And what is that? There is a condition in this probability when you find a result. What is that? Means I'm looking for the probability of the event A, provided that condition is that event B has already occurred. Means what are the chances of getting the event A or the samples in the event A once that event B has already occurred? That's my end goal. The probability of the occurrence of A, if it is known that event B has already occurred, is called as conditional probability of happening of event A. And how you write it? You write like this: intersection of the event A with B divided by probability of the event B. The expression is given as, very important expression, that P of A conditional B is given as P A intersection B upon P of B. Event A, I'm looking for the probability, B has already occurred. And of course, this has to be non-zero value for this to be undefined, or not being undefined. Okay. Now, if I go and write PBA, of course, whatever is over here, you're gonna get the same value in the denominator, because reference will be, or whichever event has occurred first, that will come as a denominator. Makes sense? And BA of A will be non-zero. As simple as that. But I mentioned this clearly, so I'm gonna help you with that also. Bayes theorem questions can be solved from here. For that, you have to do just one thing: find this result, because in Bayes theorem we use this intersection part. P of A intersection B is given by, from here you're gonna see PBA times of PA or PAB times of PB. We'll use this result a lot. I think you've seen in my other sessions where I solve questions on it. I use this result a lot for intersection, right? PVA times PA, because I can give you the formula of base theorem, but I don't want to do that. I want to always show you the approach, how the question flows with the help of conditional probability. It makes sense. It is easier to remember as well. So intersection can be found using these two results, okay? BA into PA and AB if you're writing into PB. Is this clear, bacha? Clear? Okay. Now, what is this? I'll talk about it when I go to the partition of a set, okay? Then this part will come it will become much clearer. Have next, properties of conditional probability. In this too, of course, this is also important, but for exam point of view, these two are the ones where the question actually appears from. Means you'll find the applications of these two statements very clearly straightforward. Okay, let's read from here. Let E and F be events associated with the sample space S. What it means is, it means the universe is S. In the sample space S, event is what? E and F part of that. Got it? Okay, sir. Then P of A is, F is not a, basically what it means is, F is not a impossible event. If P of A is equal to 0, we can call that to be F to be impossible event. Probability of an event is 0. It means it is an impossible event. So they're saying that it is not 0 means it is not an impossible event. Makes sense? Good. So the result is PSF or PFF is given as 1. Does it make sense? Let's write from here. PSF means what? PSF is very simple, sir. P of S intersection with F divided by P of F. P of F. What did I mention? That S is the universe and event F is part of the sample space S. So if you look for the intersection of event F and event S, you'll get what? You'll get event F only. So you'll get P of F by P of F. Check, this value cancels and answer is 1. So P of S conditional with F or P of F conditional with F is given by 1. First one is clear? Good. Next, now this is the result on unions and intersections. If you are looking for probability of the event of A union B with F, then you can write this as P of A with F plus P of B with F minus P of A intersection with A and intersection with B with F, okay, where A and B are again other two events associated with the same sample space. Means I'll have other events A also over here and B also over here. Of course there will be intersections and unions, we'll see that later, but yeah, A and B are the events. Also means total of 4 events are there. A, B, E, F are the 4 events which are part of or which are associated with the sample space S. Does it make sense? In that case, the union is defined like this: A with F, B with F minus intersection of A and B with F. Okay, sir. And this is very crucial. Okay, this can be framed as a question in MCQ of your PU2 if they want to give you a HOTS question. I have shown you a problem like that in my all-one marker. Okay, and it can be a straightforward question in KCET also, that probability of conditional probability of, sorry, not probability, probability of conditional probability of the event E dash means E complement. This is E complement with F means F has occurred is given by 1 minus same thing probability of E with F. The difference is E dash over here. Can you check this out? Complement of the event E. Okay, so remember these two, very important. Okay, this one, second one, the questions we have not seen many questions on that, but first and third directly useful for your syllabus, both examinations. Next, let's solve a question on it then. One card is drawn from a well shuffled pack of 52 cards. Okay, sir. E is the event. The card drawn is a king or queen. King or a queen. How many cards are there? 4 kings, 4 queens, means 8. 4 kings, 4 queens. And if I look to find the value of P of E, it becomes 8 by 52. Getting a king or a queen, total 8 cards are there. Probability will be what? 8 by 52. Same way. Event F. The card drawn is a queen or a ace. Again, 4 queen and 4 aces. This is what, beta? King and queen. This is what? Queen and ace. If somebody is thinking, sir, queen is already taken out, then they're not talking about not replacement. Those questions are not over here. Okay, so let's not worry about that. Just simply the statement you're gonna follow. Queen and ace. 4 queens are there, 4 aces are there. So if you have to pick 1 out of it, probability of the event will be what? 8 out of 52 again. Does it make sense? Yes. Let's cancel them. 4 2s are 4 13s are. 4 2s are 4 13s are. Correct? Okay, sir. This is 2 by 13, 2 by 13. Both of these are 2 by 13. Makes sense. Now, they're saying that find the probability that conditional event of E and F. We have to find the value of E and F. How do you find E? Conditional probability, of E when F has already occurred. This is given as P of E intersection of F by P of F. Okay. Now let's look for, from here, intersection of E and F. E means king and queens. F means queen and aces. What are the intersection? Only queens. How many are there? Only 4. If I'm looking for intersections probability, I'll get what? 4 upon 52. It means 1 upon 13. 1 upon 13. Does it make sense, beta? Yes, it does. Now let's use all the values over here. We have P of E intersection with F as 1 upon 13 and P of F as 2 upon 13. Check, 13 13 cancels. Answer is 1 by 2. Answer is 1 by 2, which is option A. Clear? Easy. So we have dealt with a very important concept which will play a big role for us to get 3 marks in our PU2, because a base theorem questions is confirmed and almost confirmed basically, and very easy problem. If you know conditional probability, any question in base theorem can be solved using the total probability and of course the partition concept we're gonna learn right now. Okay, this is clear. Moving on, multiplication theorem on probability. Okay, so we go like this. Let A and B are 2 events associated with the same sample space S. Then A intersection B denotes the event that has both A and B has occurred. The event A and B is also written as EB. Okay, so if I have P of A intersection B, I can write this as basically P of A into PBA. From where, sir? From the conditional probability. Correct, no? I just wrote this, if you check. Over here. This is the same thing, right or not? Check here. This is the same thing. Okay, where P of A is non-zero, P of B is non-zero. And if A, B, C are 3 events associated with the same random experiment, okay, then what happens is, if you're writing for 3 events, you're gonna write this as P of A, B with A into P of C into A with B. And this value becomes what? AB. Okay, AB. Now, this is where another very important concept comes back, from where the questions will come, because right now my point is not just to teach you from those concepts, but the questions can actually appear. So first one, a very crucial one. Before I go and talk about PU2 syllabus, let me tell you, for KCET aspirants, when PU also becomes very important, the basics understanding of probability is very important. Means probability of event is given by number of favorable outcome by total number of outcomes. This is one very important concept, and total number of outcome is given by that m power n, that formula. These two will play a big role to score marks of PU1 syllabus questions in probability. Okay, so remember this. I'll explain again. I'll repeat again. Probability of any event is given by number of favorable outcome by total number of event or total number of outcome. You have already learned that. Okay, and next is what? Total number of outcome is given by m power n, right? M power n, remember, m power n, where m represents your number of outcome in one event and n is the number of event. You know this much. Okay, I know you know this much. Okay, but this is very important to solve questions apart from these concepts. So that is one question that comes. Other questions are from conditional probability, independent events, and base theorem. Even partition of sets can be useful to us, but we'll see that, don't worry. But yeah, these are the important concepts of this chapter. If somebody is concerned about this chapter, let's crack it in this fashion. The basic concepts of probability, independent events, conditional probability, and base theorem, alongside with, of course, your partition of set or total probability, whatever you want to say. Makes sense? Let's look at independent events. We have learned it means when the occurrence or non-occurrence, means whether an event occurs or not, event B will be unaffected because of that. Okay, means event B's occurrence or non-occurrence will not depend upon event A occurrence or non-occurrence. Okay, we can look at many examples. Okay, we can look at many examples. For example, if I talk in a weird way, okay, basically, you remember if you are two siblings in a school, and so your sister, your brother is a very punctual one, he always gets on time, or she always gets on time and always goes to school, okay, but your mood is not always the same. You sometimes wants to skip the school, do something else, want to go for a paint, you want to you like painting, you want to go to do that, you want to play football, you want to go play basketball, okay, so whatever you're good at, better, right? So you have other things, but because of your your brother, your sister going to school, your parent, that if he or she goes to school and if you stay back at home, your parents is gonna end up scolding you or telling some things that, see, you are just sitting at home idle and your brother, your sister is already in school learning, right? So this is happening. So event of is basically him going to or her going to school will be affecting you. So in this case, it is not an independent event. Getting my point? Means if he has to go, then you are forced to go even if you don't want to go. Getting my point? So yes. So but if there was a situation that whether he or she doesn't go to school does not affect of you going to school. For example, if he or she has already passed the school and let's say going for a job or going for a college, then her or him, like basically his job to go to, his day to be in school, be in job or be at college does not affect your going to college. Okay, you can have different reasons. So in that case, the event becomes independent. I'm going to repeat again. If both of you are in school, then more likely if he or she goes, you have to go with him. Okay. But if they are, let's say working at a job, then they might go to job every day, but you might have other reasons. Okay, today I don't want to go, I want to study at home, I want to do self-study, I want to do painting, I want to go and play my game, which is there in the evening. So that's okay. So the event can be taken like that when occurrence and non-occurrence, sorry for taking too much of your time, but yeah, my point is when occurrence and non-occurrence of an event does not affect occurrence and non-occurrence of other event, then these two events are called as independent events. Okay, so this is the expression that we have. P of A intersection B is simply given by P of A into P of B. P of A into P of B. Got it? So if you write this condition, what will happen to this check here? You're going to get this as P of A intersection B upon P of B. So this becomes PA into PB, and we have denominator also PB. So cancels, so you're left with what? Simply P of A. And if you go with more than two events, like three events together, ABC, results continues like that, PA, PB and PC. These are the conditions for independent events. Okay, now before I proceed and solve questions for all of you, I have a surprise. I have to tell you all about the combo badge, the KCET-30 badge that we have launched. Let's talk about KCET-30 badge first. So this is a crash course, a 30-day online live crash course, which helps you with the right preparation, right planning, right structure to get you a good rank in KCET. Again, right now it's for boards, sir. Then why are you talking about this? Because the enrollment has already begun. People have already taken admissions for it. And if you remember, we have launched a KC90 batch. So all the students who were there already are part of this for free. Okay. So for those, if you are part of KC90 batch, this is for free for all of you. But if you have not enrolled in KC90 batch, then yes, you have to pay the amount of 2499 to get the access of this crash course KC30. And the classes start from 21st of March. Okay, class start from 21st of March. Okay, offerings are 30 days live online crash course, KCET previous year questions. So we're gonna solve it for all of you, previous year questions, and we'll also cover the whole syllabus. Means we are gonna cover PU1 and PU2 syllabus all together. Of course, after your boards are over, 17th, I think close to that, your boards gets over. Then post that, 21st February, when the 21st March, when the classes commence, you'll have the first preference given to the PU1 syllabus. In the next 10 days, we're gonna cover up PU1 syllabus, then comes back to the PU2 syllabus. Okay, chapter-wise KCET PYQs in test format. Yes, so you don't only get the solutions of the PYQs in the classes. So basically, you get one-shot lectures, you get PYQ solutions video, but you also get this PYQs in a live test format, like actually attempting a previous year mock test of KCET. Okay, so full length 10 full length mock test you also get for KCET. Okay, and this is all for 2499. This is offer going on right now for 25th February, because we have something like that. You've seen on our channel with the outservice coming, so that's why we have this offerings soon right now, 25th February. After this, prices will increase. So you have, if you're looking to get into this course, you got to get serious and take it right away. This is again club of both, means this is KC30 batch 2499, and this is what you're alongside ABHYAS test series, one of the best. I hope you have seen the results. I hope you have taken the free trials. Everything was available, and I hope you've taken up that. I hope you've given the questions, solutions of those questions. You've seen and gone through it. This again, so if you take it right now, you get ABHYAS access right away. ABHYAS comes directly to you, and KC30 batch will again start from 21st March. This is a combo, means this is a KC30 plus batch, comes at 3999. Combination of both of these, 35 mock test in this and 10 mock test, separate 10 mock test in KC30 batch, alongside the lectures, the live classes, everything will be again provided in the KC30 batch. So basically everything that you need, that you any student need to prepare well for KCET, whether you are JEE aspirant, whether you are a PU2 aspirant, whatever you are, if you're writing KCET, this will be a game changer in your preparation for KCET. Okay, now for all of you are wondering, sir, what about COMET-K? For that we are working on it. We're going to bring the crash course for that very soon. Okay, so this is, I think, clear, right guys? You can check the link given in the video's description. You're going to find the link over there. Go ahead, take the course right now, and wait for us to start the classes very soon on 21st March. Okay, again, if you're taking plus batch, you can get access to the ABHYAS free, like right away, not for free of course. It's the price of ABHYAS is also there, but you're gonna get access right away once you take the combo batch or ABHYAS test series. Okay, let's go back to the question solving now. A and B are two independent events. We learned a concept. Let's solve a problem on this. So A and B are two independent events. The probability that both A and B occur is 1/6. Means let's say event A and B probability is what? X and Y. So basically they're saying that P of this both occurs is basically P of A into P of B. This is given as X into Y, and this is given as 1/6. Okay, they're saying that neither of them occur, means they're talking about this A dash intersection. They're saying neither of them, means none of them. Okay, it'll become P A dash into P B dash. It becomes 1 minus X into 1 minus Y. I know how to find, we all know how to find complement. So 1 minus probability of the P of A, and P of A is taken as X. You can see here, this is your P of A, this is your P of B. Assumptions have been clearly mentioned over here. Okay, and this is given as 1/3. 1/3. All right, right? Okay, now if you want, you can solve these equations. You can solve from here, use expansion, find the X and X plus Y value, get a quadratic, solve it, you'll get the answer. Okay, otherwise in this question, if you want to save some time, I can go with a different approach also. Now what is that approach? Have a look. So if I have X into Y, again this is the long approach. You have to solve this. You'll get this value as 1 minus X minus Y plus XY. You have the XY value, put it over here. You'll get X plus Y as 1 plus XY minus 1/3, because 1/3 goes over there. Okay, you have all the values, find the X plus Y value. In that, use this condition, X into Y is 1/6, and get the result of X and Y both. Okay, that's the right approach, but we can be smart. We can solve it quickly without doing all the calculation steps. But what? So think about it. I want the product of two numbers to be 1/6. I can have many cases. I can have, sir, 5/6 into 1/5. What is the answer? Cancels 1/6. But I can have this also, the very common ones, and which matches my options also. Check here, 1/2 and 1/3. If you multiply them, what becomes? 1/6. Yes, sir, it means in the options given over here, we have clearly 1/3 only present. We'll take the answer D. Is it right? No, but we can verify this. We can verify this. What they're saying, this is coming from P of A intersection B. So this is validated. What about this one, beta? What about this one? This is P of A dash into P of B dash. I can write this as 1 minus P of A into 1 minus P of B. Check here, just verify once. Okay, if P of A is 1/2, this will become 1 minus 1/2, and P of B is 1/3, 1 minus 1/3. Let's cross check. This becomes 1/2, and this becomes what? 2/3. Correct now? 1 minus 1/3 is 2/3. Cancel them. 2 and 2 cancels. Answer is coming as 1 by 3. Check carefully, they have given that itself. They have given that itself as 1 by 3. It means they have mentioned the same thing. And if I take the assumption, this is my assumption, okay? Assumption to get the answer quickly. If I assume it to be 1 by 2, 1 by 3, I am able to verify both the statements. If I verify only once, I don't check other, chances of mistakes are there. But if I verify with these assumptions in both the statements, it means my answer is actually 100% accurate. Listen to me, approach I have given over here, how to solve it on the right hand side. That's the method. This is the assumption method. Okay, assume 1 by 2, 1 by 3, solve it, you get the answer. It makes sense. Answer is D. This is not the answer. Answer is over here. PB is 1 by 3. This is not the answer. This is your intersection what they've given. Okay, what is this? This is your answer. PB is taken as 1 by 3 because 1 by 2 we don't have. Check, we have two answers. We don't know which one is which. Okay, but we don't have 1 by 2. Answer is clearly option D. Makes sense, guys? Okay, let's move on to the last concept of this chapter, and that is partition of sample space. Okay, having fun in this chapter. If you have felt that probability is difficult, I do know that some of you feel that way. I think today you're gonna have some change in emotions. Okay, so it is not that difficult, it is actually very easy, and we are doing that right now in this with the help of this particular class. Okay, partition of sample space. If this whole thing is my sample space S, okay, then I can create a partition. So what is done over here, I have a sample space S. In that I have an event also, event A. I am trying to create partition in this sample space, not in the event, in the sample space, like this, okay. Sorry, my bad, there's a mistake. They cannot have intersections, no? Partitions, they cannot have intersections in partitions. Okay, so if I go like this, let's say like this, like this, so partitions will not have beta intersections. Okay, like this, okay, and so on. Basically this is 1 2 3 4 5. Okay, all right, just I've shown you 5 partitions. So if I see these 5 partitions, they have some things in common. First of all, they have nothing in common, means they're all mutually exclusive. We can call these 5 parts to be the partitions. We can call E1, E2, E3. This is E1, E2, E3, E4, E5. We can call this to be partition only when they have nothing in common. Okay, and they should be in a way, let's say if I call this to be partition number 6, the whole thing, the remaining whole thing, then if you add all of these, then they should become what? They should become the whole. Okay, that's how you create the partitions. Okay, set of events E1, E2, E3, En is said to be representing a partition of a sample space S if the following conditions hold. And the condition is what? The first condition is mutually exclusive. And second condition that I mentioned, if you take sum of all these, okay, means if you take the sum of all the, if you take sum of all the events EI from where to where, from I equals to 1 to 6 in this case, it will become the whole partition sample space. It will become the whole sample space S. It is not 5, it is S. So if you add all these, check here, if you add all the part 1 2 3 4 5 and the 6 is looking like a pentagon. Okay, 1 2 3 4 5, yeah. So basically something like that. So if you add all the partitions, it becomes the whole. So they are mutually exclusive. The first point is mutually exclusive and collectively exhaustive. Mutually exclusive means nothing in common, but collectively they are exhaustive, means when you combine them it becomes the whole. Exhaustive means they get exhausted. Okay, so mutually exclusive. And second point is basically called as collectively exhaustive. When you have these cases, then you call the partitions to be, you call these events to be the partition of a sample space. I'll again repeat, for these events E1, E2, E3, E6, I've taken 6 events over here just to show you all. if you want to call them to be partition of a set, there are two conditions. Condition number 1, they have to be mutually exclusive with nothing in common. Check here, E1, E2, nothing common. 2, 3, nothing common. 3, 4, nothing common. There's nothing common between the sample spaces, the events, and when you combine them, the second point, they are they're collectively exhaustive in nature. Okay, clear? Theorem of total probability. Total probability talks about, if I have to write probability of the event A, okay, I have to write probability of the event A. So understand this, 6 does not mean 6. I want to show this very clearly to all of you. 6 does not mean only this part. 6 is all of this, okay? This whole thing is 6. Getting it right? Yeah. So if I have to write probability of the event A, what I'm going to do? Probability of the event A intersection with sample space or event E1 plus intersection of E2 with again A plus intersection of E3 with A dot intersection of E6 with A. So to write the probability of the event A, this or this, okay, I have to take intersection of event A with all these partitions E1, E2, E3 till E power 6. In this case, I have taken E power n, so we have all the way till E power n. This is the expression for your total probability. This is important because this actually is the denominator of your Bayes theorem's expression. What you have that formula now for Bayes theorem? The denominator is this only, always this only. Remember, are you able to recall that? Yes. P of, so sir, how is this true, sir? From conditional probability. This is coming from where, beta? Conditional probability. I showed you this first slide. A E1 will be what? P A E1 with P E1. A E2 will be what? P A E2 with P E2. Same way, what is this? What is this going to be? P A intersection with E N. Okay, I hope it's making sense. Total probability and the concept of this partitions. They are basically the same thing but taken together as a whole. Making sense? Is it important? Very important actually. We're gonna give you 3 marks. Now Bayes theorem. What I was talking about? Bayes theorem talks about this statement. Event, I'm looking for probability of the event EI, provided that event A has already occurred. How do you write this? Intersection of P EI with A upon PA. How do you write this? This is the, what is this beta? This is conditional probability. Yes or no? PA intersection with EI divided by into P of EI. You're not sure? Let me write this for you. P of EI intersection A upon P of EI, right, will be given by what? P of A EI. So if you want to find the intersection, simply take the product of these two. Same thing is here. I want to find the intersection value, I get the same thing over here. And what about this? This represents your total probability. Total probability. So how will I write PA1? I'll write PA as P of A intersection with E1 plus P of A intersection with E2 plus P of A intersection with E3 all the way to P of A intersection with En. And what is the intersection going to be? Same way. I can write this as P of, AE1 into PE1, right, plus P of A E2 with PE2 dot plus P of A En into PEN. That's it. So if you want to remember the formula of Bayes theorem, do it. If you don't want to remember it, simply know the conditional probability and total probability concept. You get the whole result very, very, very easily. So yes, should know the formula to save time, but I have tried my best to help you out to understand how Bayes theorem is obtained, how do we get the result of application of conditional probability, total probability, partition of a sample space all together in the Bayes theorem. Let me know in the comment section, did it make sense to all of you or not? For all of you who were struggling earlier with this concept, is it clear now? Is the Bayes theorem, partition of a sample space, and conditional probability clear or not? I would love to see your comments in the comment section. I would love to see your feedback. What was it? Is it helpful right now or not? Okay, so Bayes theorem is over. It means the chapter is over for all of us, and now we're gonna move on to what the next chapter in the class today, which is LPP. The two small chapters that I've clubbed them together and brought it for all of you as a whole. Okay, LPP starts very basics. This chapter is everything is definition only and some basic calculations of linear programming, of course, linear equations basically. So very important to know the definitions. They might not be asked. You might not have the questions on them. It's not like they have not asked it in the past. They have. Check here, 2014, 2015, 2016, 17, 19, 22, 23. They have asked questions on these. Of the feasible region definition, they have asked 15th Jan, 16th. They have asked these questions, but maybe this year they will not ask these definitions to us. But are they useful? Of course they are. So simply go ahead. Linear programming problems definition is there. Linear constraints, objective functions. So there are many definitions over here. You can see these are also PYQs. Okay, I'm not going to read out loud for all of you. It will be boring. Okay, it's different. It's written on the screen. You can go ahead, check it out. I know many of you know the definitions very well, but it's very important. If asked, you have to write in the same way, the way I've mentioned over here. Okay, so you can see the definitions are listed over here. Feasible reason, okay, feasible solution, infeasible solution, everything is mentioned over here. You have to download the PDF and start taking this very seriously and learn, and just go through it once, learn these definitions. It's important, but it's very important for me to solve a question at least on this particular concept. So I've taken a problem over here on the screen. I'm going to solve it for you. Do you all know? Yes sir, will this question come in exam? I don't know. I'm not setting your paper, but will the same concept repeat? Yes, it will. So this is a 6-marker question for PU2. Sir, what about KCET, sir? KCET, what they do actually, in KCET what they do is, they don't ask you to draw the graph. So they'll give you the graph and they'll ask you either constraints, or they'll give you equation, they'll give you coordinate point, and they'll ask you optimized solution. Or they can give you a condition, they have you to solve and get the result. Okay, that'll be a lengthy problem. So this is the variety that they get. The same thing. They'll give you options, pick one. Okay. Same problem with the options they'll give you. You have to pick the right one. Means you have to do the whole process, but as rough, of course, you can't draw it and show the graph over there. Determine the maximum value of z equal to 11x 7y subject to the constraints over here. First thing is first, the graph. X-axis, Y-axis. Okay. I have my constraints. I'm going to take them in the form of equations. So 2x plus y equal to 6. It's easy for me to get the graph right if I can write them in the form of intercepts. So divide by 6, you get 2x by 6 and y by 6 equals to 1. Simplify them, you get x by 3 plus y by 6 is 1. This is clear. X intercept is 3 and y intercept is 6. Draw the curve. Draw the curve. X is 3, y is 6. This is 6 and this is 3. So 3, 0 and 0, 6. I got the intercept form. The curve is over here. Now look at the inequality. It is less than. It is less than means I'm looking for the reason below this. And do not forget to mention the curve also over there. 2x plus y equal to 6. Next is what? Next constraint is x less than 2. Write this. This is the first one. This is the second one. This is my curve. X equals to 2. So somewhere over here. This is x equals to 2. And I'm looking for less than. It means this is my arrow pointing out. So my feasible reason you can see now. Yeah. Now just check quickly what is the coordinate point. What is this intersection? This is the origin. Let's call it to be, what is it going to be? 2, 0. Okay, let's call this to be A. Let's call this point to be B, and this will be point C. Okay, I have to get the coordinate of the point B. For that I'm going to put x value as 2 over here. When I put x value as 2, I get 2 into 2 is 4, y becomes again 6 minus 4, so 2. Am I right? Please check once again. If I take x as 2, y as 2, yeah, correct. This is right only, right? So 4 plus 2 is 6. That's correct. So this is my coordinate point. Now let's highlight our feasible reason. This is my feasible reason because that's what I'm looking for. This represents your non-negative constraints. These are your non-negative constraint, means to keep the curve only in the first quadrant. and this is what your feasible reason. Feasible reason, clearly marked, no problem altogether. Let's write the corner points now. So we have corner points and we have objective function also. So we'll write it later. First one is 0, 0. Next one was A, I remember, 2, 0. B is 2, 2. And C is 0, 6. Am I right? Yeah. I'm looking to find the maximum value, and Z is 11x 7y. Z is 11x plus 7y. Okay. Let's put the values over here and get the results. Check. 11x 7y corner points are clear. 0, 0, 2, 0, 2, 2 and 0, 6 is all correct. Let's find it. So we'll have over here 0 only for this particular point. For this one we'll have 22. 11 2s are 22 and 0 into 7 is 0, 2. So we have 22 over here. So we get 22 and 14, that becomes 36. Am I right? 36. 22 and 7 2s are 14. So answer is 36. And the last one, 7 6 are 42. This is clearly my maximum value. So my Z max, the maximum of this objective function is 42 and occurs at the coordinate 0, 6. That's your result. Please check. Of course, statements are there, languages are there, you can write and get the answer. But approach I've given you step by step. I hope it makes sense to all of you. Is it easy? Supposed to be easy. It's a very easy question. Okay. And this is the end of your class where I talked about both the chapters, probability and linear programming. Both are discussed. Chapter number 12 and 13. The end of your PU2 syllabus. Okay, let me know how was the probability class. Did it make sense finally for all of you? Because I have seen comments that many of you are struggling in probability. So here it is. The masterstroke of both the chapters are delivered. I would love to see your feedback for how was the masterstroke. Did it benefit all of you? Whenever you need to come back and check the one-shot lecture, the theory of the chapters is given for all of you for the benefits of PU2 and KCET both. Okay, so this is it in this class. I'll see you in the next one. Till then, take care. Bye-bye.